You've probably heard the story about the salesman who was so good he could even sell a refrigerator to an Eskimo. It's not true, of course. Eskimos don't need refrigerators. They have nature's own way of keeping their food cold. But in warmer climates, refrigeration is part of our daily lives. We use it to keep ourselves comfortable, to keep our food fresh, and our beverages cold. You might say that a refrigerator works by taking heat from the inside of the box and getting rid of it on the outside. Refrigeration is the transfer of heat from a place where it is not wanted to a place where it is unobjectionable. To do this, a refrigerator uses a unit inside the box that takes up heat and a unit outside the box that gets rid of it. These units are called the evaporator and the condenser. They are tied together by connecting lines, referred to as the suction line and the liquid line. Also in the system are the compressor, which is a pump, the expansion valve, and in many systems, the receiver, a kind of storage tank. A chemical substance called the refrigerant flows through the system. It's the refrigerant that picks up BTUs of heat from inside the box and discards them outside. In the process, the refrigerant changes from a liquid to a gas. Then, in the condenser, it changes back to a liquid. At the same time, the pressure increases in the compressor and decreases in the expansion valve. Before you can understand how the system works, you must learn why and how these changes take place. That means learning some basic principles concerning heat. To begin with, take a swimming pool, and Kathy, who was swimming in the cold water. After she has dried off, she finds the air warm. But Helen has just come from the steam room, and she thinks the air is cold. The words hot and cold are relative. They are used to compare one thing to another. As the girls gossip together, Kathy gets warmer. Heat from the air passes to her body and warms her. But Helen gets cooler. Heat passes from her body to the air. Heat always passes from a warmer substance to a cooler one. If you put an ice cube into water, the water is cold, but the ice is even colder. By comparison, the water is warm. Heat will flow from the water to the ice. This changes the ice, which is a solid, to water, which is a liquid. If you heat the water, it turns into a vapor. This vapor is a gas. These three, solid, liquid, and gas, are called the three states of matter. All matter around us exists in one of these three states. Now, let's see what happens to temperature if you apply heat to the ice. The thermometer reads 32 degrees Fahrenheit. As the ice changes to water, the temperature stays constant at 32 degrees. The heat is causing the change of state from solid to liquid. Then, as you continue to heat the water, the temperature increases until it reaches 212 degrees. The water starts to boil. The temperature remains at 212 degrees. Heat from the flame is now being used not for a change of temperature, but for the change of state. Remember, heat is taken in for the change from solid to liquid. Heat is taken in for the change from liquid to gas. Now, a change of state is always accompanied by a gain or loss of heat. This is a very important point. Any substance takes in heat when it boils or changes from a liquid to a gas. And any substance gives off heat when it condenses or changes from a gas to a liquid. Here's a container filled with gas. We add a thermometer to measure the temperature of the gas and a pressure gauge to measure its pressure. What happens if you push in on the piston? Answer: the pressure increases and the temperature increases. Now let the piston out. The pressure goes down and the temperature goes down. The rule is, when a gas is compressed, the pressure goes up and the temperature goes up. When a gas is allowed to expand, the pressure goes down and the temperature goes down. It's true for any gas. Now let's see how a refrigerator works. We'll begin at the receiver, where the excess refrigerant is stored. It is in the liquid state and under high pressure. The high pressure forces the refrigerant through the liquid line to the expansion valve. This valve causes a pressure drop. The high-pressure liquid becomes a low-pressure liquid. This is like letting air slowly out of a balloon. The air in the balloon is still under high pressure, but the air that gets through expands and its pressure drops. In the same way, refrigerant that passes through the expansion valve expands, and its pressure drops. The low-pressure refrigerant flows into the evaporator. Now, if any of the food in the box is warmer than the refrigerant, heat will flow from the food to the evaporator. So, in the evaporator, the refrigerant takes in heat and begins to boil. Remember, any substance takes in heat when it changes from a liquid to a gas. The gas is sucked through the connecting line into the compressor. As the piston moves down, the suction valve opens. The gas is sucked into the compressor. As the piston starts up again, the suction valve is forced shut, and the discharge valve is pushed open. On this stroke, the gas is compressed. Remember what happens when gas is compressed? Pressure goes up, temperature goes up. The gas, now at high pressure and high temperature, flows into the condenser. The gas is hot, hotter than the surrounding air, so it gives up heat to the air. As the refrigerant loses heat, it starts changing back into a liquid. To complete the cycle, the liquid refrigerant returns to the receiver. Now let's review the whole thing. Refrigerant under high pressure flows from the receiver to the expansion valve. The valve causes a pressure drop. The evaporator takes in heat from the box. If anything in the box is hotter than the refrigerant, it gives up its heat to the refrigerant. As the refrigerant takes in heat, it changes from a liquid to a gas. Remember, any substance must take in heat in order to change from a liquid to a gas. The compressor sucks the vapor out of the evaporator and compresses it. This increases the pressure and temperature. The vapor is now hotter than the surrounding air. So, in the condenser, heat is given off to the air. As the refrigerant loses its heat, it changes from a gas to a liquid and flows into the receiver. Now let's consider some additional points that many refrigeration students have trouble understanding. In the evaporator, the temperature may be very low, perhaps 21 degrees below zero, and yet the refrigerant is boiling. How can anything boil at such a low temperature? Water boils at 212 degrees, but other substances boil at other temperatures, some higher than water, some lower. The refrigerant known as R12 boils at minus 21 degrees. There's no mystery about it. It's simply a property of the substance. The refrigerant in the suction line is carrying all the heat it picked up in the box. But its temperature is only about 5 degrees above zero. If you touch the line, it feels cold. How can something that's cold be carrying a lot of heat? Remember, hot and cold are relative terms. You know, when water boils, it's very hot, but refrigerant boils at a much lower temperature. So the refrigerant can take on heat, change to a gas, and still seem cold. Again, the reason is because the two substances have different boiling points. You have seen the basic principles of refrigeration. Study the system until you understand it thoroughly. Memorizing isn't enough. You must understand what happens and why, because all the rest of your work will be based on these same principles.